Hello everyone. Previous lecture we have studied the concept related with the subtopic here inverse trigonometric functions. In that we see how to find the principal value of the given inverse trigonometric function. Now in today's lecture we see some important examples related with the principal values. Okay, so we consider here find the principal values of the following. Let's go with our first function, and is here tan inverse of minus root 3. Tan inverse of minus root 3. Okay, now here to find the principal value we have to consider the principal value branch for the inverse trigonometric function tan. Okay, so we know the principal value branch, of function here tan inverse and is here open interval minus pi by 2 to pi by 2. Our principal value lies in between or lies in this open interval minus pi by 2 to pi by 2. Okay, so we consider given inverse trigonometric function. Consider here tan inverse of minus root 3 is equal to x. Then by using our definition of inverse trigonometric function, here I write tan x is equal to minus root 3. Okay, then I write this as here tan x is equal to minus. Now here everyone knows tan pi by 3 is root 3. Here tan pi by 3 is root 3. So we replace this root 3 by using tan pi by 3. Now here everyone knows this minus tan pi by 3 is in the form minus tan theta. And we know minus tan theta is tan of minus theta. So I write this as here tan x is equal to tan of minus pi by 3. If we compare these two, we get here x is equal to minus pi by 3. Okay, and here this minus pi by 3 lies in this open interval minus pi by 2 to pi by 2. Okay, so here this belongs to open interval minus pi by 2 to pi by 2. Okay, so here finally I write therefore the principal value of tan inverse of minus root 3 is here minus pi by 3, and this is our final answer. Okay, let us consider second example. Here in second we consider sine inverse of 1 upon root 2. Sine inverse of 1 upon root 2. Here again we consider the principal value branch for the inverse trigonometric function, here sine inverse. Okay, here we know the principal value branch of sine inverse, and here is close interval minus pi by 2 to pi by 2. Close interval minus pi by 2 to pi by 2. Okay, now we consider our given function. Consider here sine inverse of 1 upon root 2 is equal to x. Now by using our definition of inverse trigonometric function, here I write this as sine x is equal to 1 upon root 2. Therefore here I write sine x is equal to, now here everyone knows sine pi by 4 is 1 upon root 2. So we replace this 1 upon 2 by using sine pi by 4. Now we compare both these sides. After comparing, here we get x is equal to pi by 4. Now here we know this pi by 4 lies in this closed interval minus pi by 2 to pi by 2. Okay, so we consider the principal value of given trigonometric function. Here, therefore, the principal value of sine inverse of 1 upon root 2 is here pi by 4. And this is the final answer. This is the final answer. Very simple example it is. Let's go with our third example. Here in third, we consider cos inverse of minus 1 upon 2. Minus 1 upon 2. Okay, here again we have to consider the principal value branch to find the principal value. Okay, we know the principal value branch of here cos inverse is here close interval 0 to pi. Is close interval 0 to pi. Okay, now we consider our given function. Consider here cos inverse of minus 1 upon 2 as x. Now by using our definition, here I write this as cos x is equal to minus 1 upon 2. Okay, then here I write cos x is equal to minus. Now we know here cos pi by 3 is 1 upon 2. Cos pi by 3 is 1 upon 2. So here I write minus cos pi by 3. Now here minus cos pi by 3 is in the form minus cos theta. Is in the form here minus cos theta. Okay, we have to find the value which lies in this closed interval 0 to pi. Okay, and to find this, here we consider one form. Here I write this is in the form minus cos theta, and we know this minus cos theta is cos of pi minus theta. Is cos of pi minus theta. This is by using our allied angle formula. This is by using our allied angle formula. So here I write this cos x as here cos of, firstly we consider pi, then minus, here theta is pi by 3, so pi minus pi by 3. Okay, then here we get, therefore cos x is equal to cos of, now we know pi minus pi by 3. Here pi minus pi by 3 is 2 pi by 3. Now comparing both the sides, we get here x is equal to 2 pi by 3. And we know this 2 pi by 3 is lies in this closed interval 0 to pi. Okay, so this value belongs to closed interval 0 to pi. Okay, therefore the principal value of here cos inverse of minus 1 upon 2 is here 2 pi by 3, and this is the final answer. This is the final answer. Let's go with our next example. Here in fourth, we consider tan inverse of 1 plus cos inverse of 1 upon 2 plus sine inverse of 1 upon 2. Sine inverse of 1 upon 2. Now here for each function we have to find the principal value, and this principal value lies in the principal value branch of the respective inverse trigonometric functions. Okay, so we consider our first one. Here we consider tan inverse of 1 first. Okay, let here tan inverse of 1 is equal to alpha. Okay, then by using our definition of inverse trigonometric function, here I write this as tan alpha is equal to 1. Okay, now we know here tan pi by 4 is 1. So here I write this tan alpha is equal to tan pi by 4. Okay, now comparing this both the sides, here we get alpha is equal to pi by 4. We get this value and is pi by 4. Now we have to check whether this pi by 4 is lies in the principal value branch of tan inverse or not. Okay, we know principal value branch for this tan inverse is here open interval minus pi by 2 to pi by 2, and we know this pi by 4 belongs to this interval. So here I write pi by 4 belongs to open interval minus pi by 2 to pi by 2. If here alpha is equal to pi by 4, then here I write this as here tan inverse of 1 is equal to pi by 4. Let us consider this as 1. Now we consider our second function and is cos inverse of 1 upon 2. Consider cos inverse of 1 upon 2 is equal to beta. Now by using our definition, here I write this as cos beta is equal to 1 upon 2. Then here I write this as cos beta is equal to, now we know here cos pi by 3 is 1 upon 2. Cos pi by 3 is 1 upon 2. So here cos pi by 3. Now comparing both the sides, here we get beta is equal to pi by 3. Now we have to check whether this value lies in the principal value branch or not. Okay, here we know principal value branch for this cos inverse is close interval 0 to pi, and we know here this pi by 3 lies in this interval. This belongs to here close interval 0 to pi. If this lies in this interval, this pi by 3 is the principal value. Okay, so here I write this as cos inverse of, therefore cos inverse of 1 upon 2 is equal to pi by 3. Now we go with our third. Here in third given sine inverse of 1 upon 2. Okay, so here let us consider this as 2 first. Okay, consider here sine inverse of 1 upon 2 is equal to gamma. Now by using our definition, here I write sine gamma is equal to 1 upon 2. Then here I write this as sine gamma is equal to, now we know here sine pi by 6 is 1 upon 2. Sine pi by 6 is 1 upon 2. So this is equal to sine pi by 6. Now comparing both the sides, here we get gamma is equal to pi by 6. Now we have to check whether this value lies in the principal value branch of sine inverse or not. We know principal value branch for the given sine inverse is here close interval minus pi by 2 to pi by 2. And we know this pi by 6 belongs to this interval. Here pi by 6 belongs to close interval minus pi by 2 to pi by 2. So here we get sine inverse of 1 upon 2 is equal to pi by 6. We get this one. Now we consider our given example. Okay, here consider given tan inverse of 1 plus cos inverse of 1 upon 2 plus sine inverse of 1 upon 2. This is equal to, we know tan inverse of 1 is, here we get pi by 4. Okay, here is pi by 4 plus, then cos inverse of 1 upon 2 is pi by 3. Okay, then plus, then here in third, we consider sine inverse of 1 upon 2 and is pi by 6. After calculation, here we get 3 pi plus 4 pi plus 2 pi and this divided by 12. Everyone check this. Now this is equal to, we know here 3 pi plus 4 pi is 7 pi and 7 pi plus 2 pi is 9 pi. We get 9 pi by 12 and lastly we get 3 pi by 4. This is the final answer. This is the final answer. Okay, let us consider one more example. Okay, consider tan inverse of root 3 plus, with minus sign, here minus sign, sec inverse of minus 2. Here again, we have to consider the principal value, okay, for each function. Here, we consider first tan inverse of root 3. Consider the tan inverse of root 3 as alpha. Now, by using our definition, here I write tan alpha is equal to root 3. Now, here we know tan pi by 3 is root 3. Okay, so here tan alpha is equal to tan pi by 3. Comparing both the sides, here we get alpha is equal to pi by 3. Now we have to check whether this value lies in the principal value branch of tan inverse or not. We know here principal value branch for the given inverse trigonometric function is here open interval minus pi by 2 to pi by 2, and we know this pi by 3 lies in this interval. Okay, so here we get tan inverse of root 3 is equal to pi by 3. Let us consider this as 1. Okay, now we go with our second. Here given sec inverse of minus 2. Consider sec inverse of minus 2 is equal to beta. By using our definition, here I write sec beta is equal to minus 2. Okay, then here we get sec beta is equal to minus. Now here we know sec pi by 3 is 2. We know sec pi by 3 is 2. Okay, so here I write minus sec pi by 3. We get here minus sec pi by 3. Now we know this minus sec pi by 3 is in the form minus sec theta. And we know this minus sec theta. Is here sec of pi minus theta. Is what? Is pi minus theta. Okay, so here we get sec beta. Sec beta is equal to sec of. Okay, here pi minus theta is here pi by 3. Okay, this is equal to, or I write this as sec beta is equal to sec of. We know pi minus pi by 3 is here 2 pi by 3. we get 2 pi by 3. Now we consider the principal value branch for the sec inverse, and we know this is here close interval 0 to pi. Our value lies in the close interval 0 to pi. Okay, so we know here 2 pi by 3 lies in this interval. Before here comparing both the sides, we get theta is equal to 2 pi by 3, and we know this belongs to close interval 0 to pi. This belongs to close interval 0 to pi. Okay, so here I write sec inverse of minus 2 is equal to 2 pi by 3. Let us consider this as 2. Now we go with our example. Here what we have to find? Here we consider tan inverse of root 3 minus sec inverse of minus 2 is equal to, we know tan inverse of root 3 is here pi by 3. Then with minus sign, sec inverse of minus 2 is here 2 pi by 3. And lastly, here we get minus pi by 3, and this is the final answer. This is the final answer. So in today's lecture, we see some important examples related with how to find the principal values of the given inverse trigonometric functions. Thank you.